All right. What's up, guys? KhanAcademy here. So look, this is how you do number 4. So I guess first I started with this stuff here. Um, so yeah, it's just that's just the formula. Relative error equals absolute error over the measured value. And so what you have, let me get my lab notebook. So what I have here, this is important because I'm using this to calculate density. Um, and what they say is, what is the propagated relative error of the density of the unknown solution? Enter your answer in the box. You may use data from any of the 3 childs to perform this calculation. So basically, you can just use the data from M1 and M naught, and then R1 and R naught. Yeah, and so basically what you do then is, so I went here. This is my sort of third and fourth steps there. This is to calculate the absolute the absolute errors and and the value here, the like subtracted value. So that's R1 minus R naught, this one, and then that is M1 minus M naught. And so let's see. So I was actually at one of the help sessions today, and so you guys might be wondering, like, why is this? Oh God, help! Stop it! All right. So you guys might be wondering, why is this, 0.05, and why is this 0.03? That doesn't really make sense. That doesn't add up. Well, so the 0.05 thing, basically the TAs explained to us this value here, why it's not these two added. They explained to us that for a Bure, it's always sort of drop-wise in terms of, how much, I guess, like how like the measurement of each value for a Bure. And so basically that's always just 0.05. That's just established. So there's no change in that value. And then this value is 0.0003 and not 0.0002 because you are trying to take into account here the tare of the mass, right? So these two values only take into account the absolute error of the analytical balance. However, you add 1 to take into account the absolute error of the tare, or whatever error is involved there. That is absolute error. And it's weird because they assume that, if you're curious why it's not 0.004, because you would assume there's 2 tares and therefore it's 0.004 instead of 0.003. It's really, they're sort of assuming that you're only tearing once, but yeah, that's what they told us in the help session. So basically, so you get these values, right, and you have this formula, and it tells you about the relative error for multiplication and division, and it's basically just that for this value, this formula here, you get that sz over z equals sx over x plus sy over y. And so you're just plugging in values at this point and solving. So really, you're taking this value here, you're putting it there. Change colors. You're taking this value here, putting it there, and then you guys see what is happening here, right? And you also know what this little d is here. I guess that is the average density, I think. Yeah. And so basically, yeah, the average, it's the average density. And so you're using that value, and I got that value for that, and you would have gotten that, before in your lab notebook, I guess. Yeah, and so basically, you just solve that, and that gets you for well, so this part here equates to that part here, and I'm carrying this stuff over here, and then you solve for SD, and that's only in one sig fig because it's an error, right? And then basically what you're doing here, and then so that's your absolute error, right? Abs error, and this is your relative error, just because of the formula here, and here. Okay, and that will get you your percent relative error. That's your percent relative error. That's your absolute error. All right.